I'm going to talk about a project, image morphological operation. We belong to team 5. I'm going to discuss about the objectives. So here, our main objective here is to create a GUI where we can upload image from local and perform various morphological operations. Like we can upload from our local disk the images and then apply morphological operations, converting from grayscale image to binary image by estimating optical threshold using expectation maximization algorithm. So this expectation maximization algorithm is used for converting grayscale image to binary image, and also by performing erosion, dilation, median on binary image. And also we have other operations like opening, closing, open, close, close, open, boundary extension, skeletonization on binary image. These are all the operations which we are going to deal with in our project. Coming to the next slide, motivation. So this technique is used where for an image, small objects from an image and the shape and size of larger regions in the image are unchanged and is preserved. It's also applied for structuring elements known as shell in MATLAB to an input image, creating output image of same size. We have used these morphological operations in many real-time applications such as fingerprint feature extraction, recognition of the handwritten digits, license plate detection, text extraction, border extraction, and detection of imperfection in printed circuit boards. So I'm going to discuss few in detail. So coming to license plate detection, this is useful in order to for fighting crime and fraudulent things. So we can deal with these things, and this license plate recognition has many advantages like parking, access control, airport parking. Different operations like erosion, dilation, and opening are useful for this kind of detection. So any kind of fraud can be detected by using this operations. So the other one which I want to discuss is printed circuit boards. So operations like dilation and erosion also makes possible to identify the imperfections of printed circuit boards. And this is also used for detecting and testing is first converted to binary image, and then morphological operators will be applied onto the tested image, and then errors are being detected. So for detecting the errors in printed circuit boards, we use this morphological operations. And also it is used in text extraction. Coming to the next slide, implementation. So in this slide, I'm going to discuss about the functions we implement to perform image morphological operations in detail. Coming to the first one, binarization using expectation maximization algorithm. In this method, grayscale image converted to black-white image. It works by finding threshold value of grayscale and whether a pixel having particular value. And I'm going to discuss in detail about expectation maximization. So let's consider the threshold equal to k by 2. Now we'll be able to divide the histogram into two parts, compute the means of histogram individuals, say those two values as peaks. Now given those two peaks, estimate the new threshold using those peaks. Split up again by using the threshold, and this process continues until mean does not change anymore. So using this algorithm, we are going to do the binarization operation. So coming to the next one, image morphological operations in dilation and erosion. In dilation, it adds pixel to the boundaries of objects in an image. And in erosion, we can see it removes pixels on object boundaries. It also is used to process the pixels, which defines the operation as a dilation or an erosion. If dilation enlarges an image, then erosion shrinks the image. The way the image is shrunk is determined by structuring the element. So here are the operations which are used, which are known as dilation and erosion, and they are represented by the symbols which are mentioned here. The way the image is shrunk is determined by structuring the element. And we have the other operations known as open and close. So for open and close, generally we do not affect object size. So opening of an image, placing them in background, while closing remove small holes in the foreground, changing small islands of background to foregrounds. Closing is to remove background pixels then that fit the structuring. It actually tends to close gaps in image. And this is the notations which are given for opening and closing of an image. And coming to open, close, and close, open. These operations are quite similar. Both remove two small structures without affecting size much. But open, close tends to link neighboring object together, and close open tends to link neighboring holes together. So these are the similarities. Coming to the boundary extraction, applying boundary extraction, this field is used to calculate difference between input image and eroded image. The boundary will get in black color and the rest will be in white color. This is the notation, how it is presented for boundary extraction. Coming to the implementation of skeletonization, we can see the way of obtaining an image's medical access or skeletonization. It is a process of reducing foreground regions in binary image to skeletal remnant that largely preserves the extent and connectivity of original image, while the ongoing things are throwing away most of the original foreground pixels. And implementation of GUI. We used tkinter, a Python interface for TK GUI toolkit. It is a Python building to the TK GUI toolkit. It is the standard Python interface and which is useful and available in most of the operating systems. Challenges we have faced during this implementation of GUI is we are much clearer on morphological operations, but we have faced challenges in implementation of GUI, unable to change the input number, that is structuring element for each morphological operations unless exiting the program and running it again. One of the main challenges we faced is during the coding is reducing the time of execution, iterating through each pixel of morphological operations increases the time complexity. Another challenge we faced was trying to replicate the results of inbuilt image morphological operations like erode and dilate. Now I'm going to explain the project. This is our code showing image morphology.py files. We have all the operations present in this, which we discussed right now. So I'm going to show how this code is going to run. When I'm running the main.py file, this is the pop-up GUI, which is popped up in our project, having all the operations binarize, open, close, erosion, close, open, dilation, boundary extraction, open image, skeletonization, close image, medium. So when I'm giving this input value and when I'm browsing the file, which is in my documents, and when I click binarize, so this is the binarized file which I have got. This is the input image and this is the binarized file. So we got the input image and the output image after the binarizing, after clicking binarize button. Now I'm going to browse another file. When I click this and when I give open, close, so this is our open closed image, which is obtained after using this operation. This is the input image and the output image to the right. Now again, I want to check for erosion. When I want to check for erosion, I'm checking out the file. I'm giving the input image and I'm giving the erosion. So this is the image which is eroded, or this is the input image to the left and this is the input output image to the right. Now let's take for close open. When I have selected this image and now when I click close open, I'll be seeing my input output image for close open operation. This is my image for close open. Now I will look for dilation. Now we have obtained image for dilated. This is the input image and this is the output image for the dilation. Now I'm checking for boundary extraction. Now I'll browse files for boundary extraction. Now we got the image for boundary extraction. This is the input image and this is the output image. Now I'm checking for open image. So for open image, this is the input and output image which we have obtained when we have clicked on that. This is the input and this is the output. So now for skeletonization, when I'm checking, so when I browse file, in apply skeletonization, this is the skeletonized image which we have received after giving the operation of skeletonization. This is the input image and this is the output image. So now I want to check for close image. When I select this image and give close operation, so this is the closed image which is obtained after performing close operation. This is the input and this is the output. When I'm looking for median and when I give the input file from my local files and click on median. So this is my image for median. This is the input image and this is the output image when I applied median operation. So all these operations are performed and this is the output which we obtained and this is our GUI. And now I'm moving on to next slide, that is conclusion slide. So I want to conclude my image morphological operations. The main goal of using image morphological operations is to adjust the imperfection in the structure of image. It has powerful tools for extracting features, and dilation and erosion are primary of all the operations, and it is having many advantages in many fields, as we discussed earlier, in many scenarios in real-time applications. And we can say that it's very much reliable to extract attributes of image. And also we can say these operations are really very much useful, and the operations of closing, opening, and the combinations of dilation and erosion, and all of this are used for occurrences changes the nature of the output. So this is all about our project and I'm concluding it. Thank you.